Question number 3 in the free response section is a non-calculator problem, and it gives us this diagram, and this diagram is a function y equals cx square root 4 minus x squared, where c is a positive constant. And question number 3 says, a company designs spinning toys using this family of functions. The figure above shows the region in the first quadrant bounded by the x-axis in the graph of y equals cx square root 4 minus x squared for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved around the x-axis. So we're going to spin this area around the x-axis, generate a 3D solid, and both x and y are measured in inches. So part A says, find the area of the region in the first quadrant bounded by the x-axis in the graph of y equals cx square root 4 minus x squared for c equal to 6. Okay, so we're going to find the volume of this object. So we need to set up an integral. So the volume is going to be equal to the integral of this function. So 6, we're going to replace that c with a 6. And so we get 6x square root 4 minus x squared. And we give it some thickness dx, and then we're going to sum it all up. So to do that, we need to have the bounds. So we're going to solve this equation for the roots. And the roots of this function are going to be found from the square root here. So we're going to get plus minus 2. So we know that that endpoint is 2, which I've drawn on the diagram. And then we also get the 0 here. So it's going to start at 0. So our bounds are going to be from 0 to 2. Okay, so now we set up the integral. We just have to find an antiderivative to be able to evaluate this integral. However, when we look at this integral, we have an x on the outside and an x squared on the inside of a square root. So this can't be antidifferentiated using some basic power rule. We have to recognize that this is substitution. Okay, so this is important that we use substitution. So use okay, and when we use substitution, we're going to try to find an inside function whose derivative can account for what's left over on the outside. So when I take a look at this inside, and there's really not much choice, we're going to have to choose that inside 4 minus x squared. We can let u equal the 4 minus x squared, and the derivative of that is going to be negative 2x, and then we move the dx to the other side here, and we need to see if that can account for what's left over on the outside here. So I'm just going to rearrange this because I noticed that we have in here, we have our x dx, okay, and that can be accounted for in this expression. So if I rearrange this, du over negative 2, there's my x dx that I can replace. And I can replace that with a du expression. So my new integral is going to look like this. So I'm going to take that 6 out on the outside. It's going to be from 0 to 2. We're going to take the square root of u. We're going to replace the inside with u. And then we're going to replace the x dx with a du divided by 2. Okay, so that x dx I'm going to replace with a du, and I'm going to put the divide by 2 on the outside. So divide by negative 2 on the outside. And because I'm now using u's, I need to change my bounds to x equals 0 to x equals 2. Okay, just to indicate that we're not using u bounds here. So now I have an integral that I can antidifferentiate. So I'm going to go v is equal to negative 3. The integral of square root u is going to be u to the power, increase the power by 1, so 3 over 2. And then we're going to divide by 3 over 2. And we're going to evaluate this integral from the bounds of x equals 0 to x equals 2. Okay, so I'm just going to clean this up a little bit and replace the u. So v is equal to, and I'm just going to color code this so we see where all these parts are coming from. Okay, so v is equal to, the negative 3 divided by 3 is going to be, to cancel out. So we're going to cancel those out. Divide by 1/2 is going to be times by 2. And then I'm going to replace that u with the original x expression. So that's going to be replaced by 4 minus x squared. And then the bounds are going to be from x equals 0 to x equals 2. Now, since we're back with x's, we can just leave out that extra x equals. So now plugging in my bounds, I'm going to end up with negative 2. And plugging that in, I end up with 0. 2 squared it minus 4 is 0, so I end up with 0 minus. And when I plug the 0 in, I'm going to end up with the square root of 4 cubed, so I end up with 8. So when I evaluate this, I end up with positive 16. And that's in inches squared as my area. So for c equals 6, the area bounded, that area there in yellow that's bounded is going to be 16 inches squared.